Hello Synapse community, my name is Ryan Magitimer. I'm a product manager on the Azure Synapse Analytics team. And that's right, it's 2023 and we've got a new look. So let us know in the comments. Blue, hot, or not? At any rate, for those of you in the know, it is the January 2023 Synapse Update. Also, I'm sure all of you are well aware, but if you want to know detailed information, links to docs, all that cool stuff, check out the monthly update blog. You can find a link in the description for this video. Well, let's start things off with Apache Spark Advisor for Azure Synapse. Spark Advisor for Synapse is a new public preview feature for Synapse notebooks. It has built-in patterns to auto-analyze notebook code and offer real-time recommendations when users run notebooks. Spark Advisor contains three types of device: info, warnings, and errors. When I execute a notebook cell and the execution fails, Spark Advisor integrates with Impulse and displays the error analysis results right below the notebook cell. I can click the error advice icon. Here you can see that two pieces of advice have been generated. One is the grouped info of the task failure summary for failed job along with error stack trace. The other is a device for a file not found exception, which also includes the troubleshooting guide. Spark Advisor also offers warning type advice even if the notebook cell runs successfully. Data skew is a common issue. Spark Advisor also covers the skew analysis. When I execute Spark jobs, a few tasks are more skewed, leading to data skew. I can get the metrics summary table right here. I can get the stage ID where the skew occurred, the maximum and average amount of data read in that stage, and the skewness coefficient of the tasks in this stage. Lastly, Spark Advisor offers info type advice. This info advice is usually from best practices and could improve Spark execution performance or consistency. One example is optimizing the delta table with small file compaction. If a query for a delta table has too many small files, the query read speed will be slowed down. The Spark Advisor will suggest running the optimized command on the delta table to enhance the performance of queries. That's a quick glance at the newly released Apache Spark Advisor for Azure Synapse features in Synapse notebooks. Let's move on to Apache Spark 3.3 for Synapse. One of the top announcements we had recently for Azure Synapse was the preview availability of Apache Spark 3.3 for Synapse. Some of the essential changes in this update include features which come from upgrading Delta Lake to version 2.1. Let's take a look at two features coming with Delta Lake with Apache Spark 3.3 for Synapse. We're going to look at the optimize command with the order option. To start playing with Spark 3.3 in Synapse, you need to create a cluster that's running Apache Spark version 3.3. I have a cluster running all up and ready to go here, and I use it to execute this notebook. To get this notebook started, I created some data and wrote the data to a temporary view. Based on this data, in this temporary view, I created two tables. The first one is called trip and stores the data in my sandbox layer in the trip folder. The second one is called trip optimized Z order and is stored in the corresponding folder. Now let's see what the difference is in the files behind both those tables. Let me switch to the Azure Storage Explorer. On the left side, you have the files that are behind the trip table. Notice that most of the files are about 150 to 160 megabytes. On the right side, we have the files that are behind the trip optimized Z order table. Notice that those files are much bigger. This is because the optimized command coalesced these files into larger files, so it actually makes the listing of files quicker for serverless SQL. If you think about querying, you may see that the queries will read fewer files when required to return results. Now, let's see what the impact of Z order is on the queries. This is a sample query that takes the data for a specific date from the data stored behind the trip table and calculates the average tip amount based on the passenger count for the trip. So now I can see my results set. Taking a look at the Messages tab, I can see that the data scanned for this query was 378 megabytes and it took 3 seconds. Now let's look at what the result is for the second table, trip optimized Z order. I took the same date and performed the same calculations this time. This took about 3 seconds, but if I switch to the messages, I can see that the volume of data scanned by the query was over 10 times smaller, which impacts the cost of my query. So, Z-order can dramatically impact how much data is scanned by queries over the Delta Lake. This is actually using data skipping algorithms, so you can see many queries become far cheaper than before. The second feature of Delta Lake that was introduced with Apache Spark 3.3 that I'm going to cover is time travel support in SQL language. Here I'm in my notebook and I'm using the Spark M1 cluster, just like the previous demo, so it's running Spark 3.3. I have my Delta table ready to use. Now, the trips table contains trip data. Notice that the trip ID number 1. I have passenger count equal to 1. That will be an important detail later on. Now, let's just check if the table is really the Delta format table. I run describe detail on top of my table and see what the format is, and it's Delta. If so, then I can run my DML commands like update. I can change the data here to update the passenger count to 3 for trip ID 1. Notice that this specific command affected 1 row. If I now select the trip ID and the passenger count from trip ID 1, I'll see the updated passenger count. Using the time travel feature of Delta Lake, I can see the history of updates on this table. So I can see, for example, using the describe history, that there are 2 versions of my table. Version 1 appeared after I executed the update command. So, how can I use historical versions of the data in my table? I can access those versions using 2 options. One is the timestamp as of, where I can point to a specific timestamp that corresponds to a specific version of my table. I can check what the value of any column existing at that time in my table. I can see the historical version of the passenger count for trip ID 1 was 1. I can also use version as of. Here, I specify the version number. In this example, I take version 0 coming from my table history. I can see the same result set that tells me what the value of passenger count column was for trip ID 1. Well, that wraps up our video for today. We covered Apache Spark Advisor as well as Spark 3.3. Let us know in the comments. Were those your favorite features, or maybe there's another feature this month that you liked better? Again, my name is Ryan Magitimer. You can find me on Twitter. You can find Synapse on Twitter, Azure_Synapse. And if you like social media, if you like Twitter or LinkedIn or whatever other social media you might like, we've got just the program for you, the Azure Synapse Influencers Program. We've got titles, Champion, Challenger, Contender, all exciting titles available to you at an instant by signing up with the link in the description. There's also swag, private events. We regularly call out people in the community. Big surprise. This is a great way to see who's active and we can amplify you. It's very exciting. All of the cool kids are doing it. At any rate, like, comment, subscribe. Thanks for watching, and we'll catch you on the next one.